Okay, here we are back to our videos. Hope you enjoyed your break and are doing your homework tonight. Here is your first video of chapter 6. We do have 6 sections, and we did sections 6.1 and 6.2 today in class. So here's section 6.3. Title is Perform Function Operations and Composition. So for vocab, we have they're defining the power function, which is nice. Again, Algebra 2 is a kind of an exploration of different functions. We just finished the polynomial functions, and this is the power function. Power function is in the form y is equal to some constant. So let's just make up an example. 2 is a constant. X to any rational number. So rational number I could put 2 here, I could put 4 here, I can put 1/3 here. I'm going to put 1/3. And that is your power function. Again, this number here can be any rational number, and there can be any constant. That's called the power function. It's a pretty big function as far as all the different options, but we'll deal with a few of them. We'll do the square root function, or the 1/2, and we'll also do when we're in the rational number could be 1/3 as well. All right, so the second vocab is composition. Composition of a function g with a function f is h of x is equal to g of f of x. That's quite a mouthful, right? The composition function, we take one function and we insert it into another function. So we'll do more in this. We really need to do examples for you to understand this. But again, composition functions when you take a function and insert it into another function, and then it gets called a new function. So it's heavy on function notation. The domain, again, domain means all the values for x of h is the set of all x values such that x is in the domain of f of x and in the domain of g of x. So domain is an interesting thing when you do composition functions, something you need to keep an eye on. So check this out. We are going to do different operations of functions. So we're going to define two functions, as one function as the f function and another as the g function. And we can make up new functions, right? The h function, if I decide to add the two functions. And quite easy, right? If you add f of x, which is 3x, and add it to g of x, which is represented by x plus 3, your new function is just 4x plus 3. Again, domain is always a concern with certain types of functions. Here, you can plug any value in for x, right? These are both lines, and so lines typically, unless they're vertical lines or horizontal, have pretty universal domains. And so here, the new function h of x has the same domain as the original functions, all real numbers. I could subtract the two functions, so f of x minus g of x is 3x minus x plus h. And here we have to be careful with the distribution of the negative. And so your final, function h of x would be 2x minus 3. And we can multiply functions. So we take f of x plus g of x and we simply multiply it. Again, distribution here will give you your, arrow got a little out of control. We'll give you 3x squared plus 9x as your new function. Again, no restrictions on the domain. This gets a little bit more interesting, right, where two lines become a parabola, but the domain is still all real numbers. And then finally here, when we divide, and dividing causes an issue because it would be 3x, the line divided by x plus 3, but right here we're very concerned because we cannot divide by 0. So if x becomes negative 3, this h of x function would be undefined. So your domain gets a little more restricted, so we would want to keep an eye on that. Let's do two examples. Let's start by just adding and subtracting functions. And so you can see here that those lines became a little bit trickier. Now we're dealing with a power function, and the power here is 1/2. It's also called the square root function. So first I'm going to add the two functions. So f of x plus g of x, and here hopefully you can see that this would give you, because we have the variable x to the 1/2 is the same, this would be negative 2x to the 1/2 power, and we're allowed to add. Again, the reason I could add them is because of the x to the 1/2 and the common x to the 1/2. Here, when I'm subtracting, I need to be careful with the double negative, and I'm actually just going to add and say that's 8x to the 1/2. And then both of these functions, they have the same domain, right? This is the square root of x, right? So this would look like the square root of x. And here you should say, oh, I can't take square root of negative numbers, so this would be all positive x greater than 0 and equal to, right? We can take the square root of 0. And then the domains for these two answers would be the same, right? Would be the same. So x greater than and equal to 0. All right, nice job. Keep going here. Oh, what are we doing? We're multiplying and dividing functions. So two different functions. Looks like the f function is a line, right? 7x. And then this guy is another power function. The one, this is the sixth root. Oops, let me see if I can do that. Sixth root of x. And I know that even powered roots, x has to be positive or 0. So this guy has a pretty restricted domain, the g function. The f function has no domain issues. So here when I multiply the two functions together, I get this. And then here, this should remind you, and this is why the rules are so important. This would be 7, right? 7 times there's a 1 here. And now what do I do with this x to the power 1 and x to the power 1/6? Hopefully you're yelling at the screen saying, you add the exponents. Excellent. Or just you said it. But this would be x to the power. And this would end up being 7/6. Right? 1 plus 1/6 is 7/6. And then here, if I were to divide, I would have 7x over x to the 1/6. And then what's the rule for exponents here? That would be subtract. So your final answer would be 7x, to the 5/6. Hope you can read that. That's the 5/6. Great. And so the domain, again, we said of f, the line is all real numbers. I don't know if you remember that symbol. I like this cool looking R. And then for the domain for g of x would have to be greater than or equal to 0. And then notice for both of our new functions, right, we're still dealing with that radical 6. So they would both also have to be here we go. Sorry, that when you multiply the two functions, let's just write it here. It makes it so much easier. So this guy would still, the domain here would be x would have to be greater than or equal to 0. And for this one as well, right, because we're taking the sixth root, x would have to be greater than or equal to 0. Excellent. I think it's time for you to try, right? So we're defining two functions here. They're both power functions, right? And notice they're both the same power, 3/2. So it should make it easy to add and subtract, multiply and divide, and then maybe think about the domains, right? This is x to the 3/2 will be the square root, so you have to have a domain of greater than or equal to 0. And I forgot to tell you to pause. Hopefully you paused the video. Here are the answers. If you didn't pause, go ahead and hit pause now and try these. But here are the four answers, for adding. Adding was pretty straightforward, right? 5 minus 2 is 3, and then 5 minus -2 would be 7. When I showed you a little bit more of my work. Sorry, it's a little bit illegible. But when I multiply, 5 times -2 is -10. And then what do I do with these two exponents? I add them. So again, your rules are going to be so important here. So 3/2 plus 3/2 is 6/2, which is 3. So your final answer should have come out to -10 x to the third. When I divide here, you can't really divide 5 by 2, so you write 5/2, and it is negative. And then you subtract the exponents, you get x to the power 0. And hopefully you do remember that anything raised to the power 0 is just equal to 1. And so we're left with -5/2. Again, your domain restrictions is going to be the same, all positive real numbers, or maybe you wrote x is greater than and equal or equal to 0. Nice job. So our last bit here is called composition of functions. I think this schematic is just really, it's pretty outstanding. And, it's a hard concept to show in a diagram. But again, composition function is when you take one function and substitute it into the other. So you would take something, plug it into the f function, get an output, and plug that output into the g function and get an output from the g function. So I always think of it as kind of a leapfrog thing. You know, you're plugging an answer into a new function. Let's go ahead and look at an example, see if this starts to help. So here we've got f of x. This is a power function, right? This is x to the power -1, and then you also have a linear function. We would like to figure out what f of g of x is. And notice there's a difference between that and g of f of x. So here we're going to take the g function and substitute it into the f function. Here we're taking the f function, substituting it into the g function. So here, look how this works. We are going to take g of x, which is 3x plus 5, and we're going to insert that into the f function. So this ends up looking like this. 6, right? Notice I'm here looking at the f function, 6, and then instead of writing x, I'm going to write 3x plus 5. I'm going to try to write that. Minus 1. So again, your g function is this piece right here, the 3x plus 5. It got inserted where there just used to be an x, right? And so you could clean this up if you want. This really should be written as 6 over 3x plus 5. We're not allowed to write negative exponents in our final answers. And here you could see you've got an issue with the domain. If your domain comes out to be, or that if I set this equal to 0, and solved, I should get -5/3. And if x became -5/3, we would divide by 0, which is not allowed. So the opposite way to put the f function into the g function, I'm going to put this function into the g function. So I'd rewrite that as 3, and instead of writing x, I'll put the g function, or excuse me, the f function in, which is 6x to the -1, and continue plus 5. So you really have to be comfortable with function notation and substituting in, right? So again, almost like I said back in chapter 2, try to be a robot here. This is the f function. Whatever you see here, write it and substitute it in for x. So it'd be 3, whatever that f function is, just write it, 6x minus 1 and plus 5. This can get cleaned up, right? This would end up looking like 18 over x plus 5. And again, we have a big issue with this function because if x is, somebody tries to plug 0 in for x, this would, 18 divided by 0 is undefined, and this function does not give you an answer. So that would be our domain restriction. Here we're doing, and you're allowed to do this, I like the example, you can take the f function and just plug it back into itself. So you would write here 6, and instead of just x, you would replug it, plug f of x into it, and it would look like that. So again, what used to be 6x minus 1 now becomes 6x minus 1 raised to the -1. It's starting to get pretty confusing. Can this get cleaned up? Sure can, right? This would end up looking like 6, and then I'm going to distribute this guy in. This would be 6 to the -1, and x to the 1, right? Because I would multiply -1 and -1. So this would really just be x. That neat, right? 6 to the -1 is 1/6. 1/6 times 6 is 1. Pretty neat answer. And I think we talked about all the domain issues already, so I'm going to skip those just for the sake of time. Hey, if you could you really, this is so important, can you try your hardest to plug this in? Try to do f of g of x. So take this g expression and substitute it in for x here and see if you can clean it up. And then do the opposite. Take this f function, this whole piece, and substitute it in for x. And then finally, try to substitute f in on itself. If you want to think about domain as well, that'd be great. But really do the composition function the most. Hit pause, and when you're ready, hit play. And here are the answers. So in red, there are the answers. I wrote it here, and hopefully with some color, it helped. So first, when I take the f function, I write 5, and instead of writing x, I substituted in x, or excuse me, 3x to the -1. And here you can see the substitution as well. I put the f function in the g function. And finally, I put the f function back in itself. And then you need to clean things up. Looks great. I will see you tomorrow.